Thank you for joining us today at the Project Management Institute's Sustainability Summit 2023. We hope you enjoyed that session and will stay tuned for our next one.
I recently realized that 60% of the total global carbon budget for a sustainable planet has been consumed during my own adult lifetime. It's my generation that's caused a large part of the problem, so we should also step up towards solving this. The backdrop to this video is a photo from my favorite place to walk, Maria Alta Bos in Flanders in Belgium, close to where I live. This June, after a month of high temperatures and no rain, it was tinder dry. I was really concerned about the risk of forest fire. However, it rained a lot during July, so that risk has gone away, at least for now. We all need to join together to fight the climate crisis, as individuals, as professionals, and as members of the PMI. I think that as project professionals, we have a unique set of skills and the required global scale to make a massive positive impact. Let's make this event an important step towards achieving global sustainability.
Hi, everyone, and welcome to this episode of the Salt Witch Chronicles. Today, we're looking at the energy system. We've been going through 6 systems for transformation, and now we are at energy. And we're also going to be thinking about the idea of a black box, which is an idea in systems thinking. So sometimes when we're defining a system, sometimes it's easier just to say, and there's a black box there and things happen in it. And you don't necessarily need to know all the inner workings of it. Other times, so on the right hand side, we've got a black box recorder, which is actually bright orange. Sometimes it's very important to understand exactly what's happening inside a system, especially if it's not working. And so here's one example. Let there be light. Most of the time, you just want to know that if you press the switch, the light comes on. And that could be true in systems. Sometimes you just want to know, I put this in and this comes out, and I don't really need to understand why. But if the engine warning light has come on your car, there's only so much that you can gain from looking at the engine warning light. Possibly you will have realized that your car is not moving. So you do need to, pop the bonnet, open the hood, and have a look inside and see what's gone wrong. So for this talk, rather than a sort of broad sweep, which is what we often do, we're going to look in sort of micro level detail at the specifics. So firstly, kinetic energy. So kinetic energy is a type of energy that's about movement. So we've got that moving car there. And then another type of energy is heat. This is going back to GCSE science. Thank you, GCSE Bite Size website. And we have our closely related cousin, light. Heat and light often come together. Another form of energy is gravitational potential energy. And the example here is a big dam. So all that water being held back by the dam is holding gravitational potential energy, which is why when you release it through the dam, the water flows through and you can use that to generate electricity. Another form of energy is sound. And then some of the ones we use quite frequently. So chemical energy. Chemical energy is often how we store energy, or it's a type of energy vector, which means how I move units of energy around until I want to use them. So wood is a form of chemical energy. Batteries, the way they store their electricity is through chemical energy. Natural gas, coal, petrol, diesel, so lots of our fuels are chemical energy. And food is often chemical energy, so I can inform you that churros are a kind of energy. Then there's electrical energy, so whether that be lightning or electricity in the power network. Elastic potential energy or strain energy, so that's the type that's found in coiled springs or the bow there that's been drawn back. That's another good way of storing energy. Then nuclear energy. So sometimes fusion in the solar system, but generally on Earth we use fission energy. Then there's magnetic energy. So that's the energy associated with magnetism. Bit of a mystery. And one of the things that we do, as I say, with energy vectors is we transfer one type of energy to another type of energy. So in this one, we're transferring chemical energy in the form of diesel or gas to kinetic energy, which is usually moving a turbine, to electrical energy when we put it through something like an alternator, and have created electricity. Or for another one, coming out the other side, I've got electrical energy here. And as I said, heat and light are often cousins. So I've got heat and light being transferred there in this electrical heater. And sometimes there are losses. So this one is taking kinetic energy to kinetic energy in the form of wind to the sails, to the gears, to the grinding stone. But there'll be losses in heat in terms of friction and also sound. So if we go sort of to talk about the development of energy, so Henty here, this one person, a human can work relatively comfortably at about zero point 0.1 horsepower. So the amount that Henty could get done in terms of ploughing a field or something like that is about zero point 0.1 horsepower. So your fields are generally quite small. Once we start to domesticate oxen and things like that, which run at about 0.6 horsepower, the amount that people can plough goes up a lot. And modern tractors run at about 50 horsepower. So that's a little bit like having 50 horses that never get tired to pull your plow around. And that's one of the reasons we've got so much better agriculture. And apparently, modern sports cars can have up to 1,000 horsepower, which is very impressive. Or if we take a different example, say Henty wants a hot drink, and we've moved from horsepower to kilowatt hours, slightly different unit now. Now, of course, Henty is never going to get a hot drink from a horse. Bad luck, Henty. So let's instead go for different types of fuel. So if we were burning wood, this is not accounting for losses, by the way, so you would need more than this because obviously there'll be losses, but you need about 20 grams of wood to heat your litre of water to boiling, but only about 10 grams of coal, which is one of the reasons people started using coal, is because its energy density is higher. Natural gas, you only need about 8 grams of natural gas, so the density is even better. And of course, in terms of modern electricity, I mean, you just flick a switch. So some of the problem with getting this more and more dense energy and getting better and better at using it, of course, is the carbon emissions that go with that. So natural gas is currently running at about 180 grams of carbon per kilowatt hour. So boiling this kettle and heating my litre of water is going to be about 16 grams of carbon. For electricity, it's running a bit higher and it would be about 23 grams of carbon. But what's interesting is that in 2008, it was higher still. And so the electricity is getting cleaner, which is a good thing. In terms of fuels and cost, one of the things we need to think about is whether the price of energy is going up or down. And of course, at the moment, energy is quite expensive. So boiling the kettle is going to cost about 0.6p if we do it with gas and about 2.4p with electricity. And the dilemma here is that it's probably going to be easier to decarbonize electricity, but it might be dearer. So it's important to understand as we try and decarbonize, we're trying to give people access to both clean and affordable energy. And that's some of the decisions we need to consider. Thanks very much.
Creating a more sustainable future is the challenge of the century. Together, we can engage, inspire, and mobilize for action to improve the situation for people and the planet. How? Through the power of projects. Project management brings together the why, the what, and the how. Let's come together to use our skills for action. Please get ready because the next session is about to start.